Hello, I'm gonna show you how to make a posture corrector. Okay, basically it's something that we put on our back, and it vibrates once we tilt too much. Alright, so I'm gonna start with the components. Okay, this is a Bluetooth device using Arduino platform. Specifically is a Pro Mini board, right? 3.3 volts and 8 megahertz. I used this because this is going to be battery powered. Alright, so of course we need something that tells us when we are in a bad angle or posture. So okay, I'm gonna show you. This is the prototype. Doesn't look very neat, but it works. Alright. So this piece of metal in here is a vibrator, alright? I don't know if you can see. Okay, this piece of metal in here, alright? So this came from an old mobile phone, right? So this is what is gonna tell us when we are in the angle that is bad for our back. Alright, so next component, we need a sensor. Tells the angle to the microcontroller. So we used an MPU 6050. This is a gyro and accelerometer module, right? This one in here, okay? It has to be in this position, okay? I would like to put it horizontal, but it doesn't work. Anyways, so next thing we need to drive the vibrator. We need a BJT transistor hooked up with a resistor in here. It's a CH340g transistor, NPN, I believe. And of course we need a battery. It's located in here, in this sandwich. In here, this is a Lipo Battery, 250 milliamperes hour. All right. And how do we communicate when this is in our back? Okay. How can we do it? So we need some sort of Bluetooth module. All right. This one is the 2.0. It didn't work for this project. I don't know what happened. You need perhaps it's because of the mobile phones nowadays are all 4.0. So you need the 4.0 module equivalent. Right, those are the main components. All right, and I missed this. You need a USB to UART in order to program the chip, and of course you need this is the standard one, the standard module to charge the battery. Okay, so I'm gonna show you the code. after this. Right. So firstly, you need to include all these libraries for the sensor, the gyro and accelerometer sensor. This accelerometer goes through by I2C comms, so you need this library. This one is default in order to work with Arduino. I did try low power mode. I needed to do a little bit of research with this. Anyways, we got with 250 milliamperes hour. We got around 2 hours and a half battery life in the worst scenario. Okay. In the best, without using too much the vibrator, it can last around 10 hours, 9-10 hours. So it's not bad. Perhaps it's not necessary. Perhaps you can make that up with a larger battery. All right. This is the EMA filter we are going to use for the signal processing. This is a low pass filter, okay, and this one is for the serial comms, okay, and we got here 2 more for timers. So most of libraries are already done by someone on the internet. I just found them. So we start with timers. In here I used 3 in the beginning. Finally I just used 1. Okay, these are all the variables. Here I used, then this one is the gain for the EMA filter, the low pass filter, the signal coming from the sensor. Because this I made this regarding, and you can use it sat down on a chair and walking as well. So walking, you need a low pass filter in order not to charge in order not to activate the vibrator motor when you are walking, okay, because of the accelerometer is very sensible. Okay, so sensitive, sorry. So this one is for one timer I didn't use at the end. This is for all the battery levels, alright. I used an internal reference from the Arduino and compare it with a voltage divider with 2 resistors hooked up to the chip, and well, this is what finally at the terminal, Bluetooth terminal on your mobile phone, you will find this test saying your battery level, and it indicates what angle. Okay, it says sets your vibration angle. I just used the ADC scale, so in order to adjust, you just put one value between 0 and 1023. So that's pretty much it of this. And this one is for the Bluetooth comms. This comes from the internet. Someone did it already. And this is the internal reference for the battery level, the comms speed, initialization of the sensor of the okay, this is I didn't remember, for starting to I2C comms, and then the gyro initialization, and you got the timer settings in here, more settings in order to start the timers, and the pin modes. Okay, I used. So we are in the loop main program. This is for a timer in order to update values. I used a delay. Eventually I will use timers as well for this. Anyways, it works like that. It's not the best, but so here you got the acquisition of how this comes from a library already done, of course. Everything, you know, I'm kind of a beginner in programming, so most things I just from the internet. It's already done. Just have to look for them. So these are part of the work I did, but I didn't apply at the end. More work, dancing around and everything. And then you got this comes from same package from the gyro, for the gyro and accelerometer. Acquisition, so this it calculates the angles with these formulas, and the angular accelerometer and the rotation of the gyro, and it had to adjust, of course, the gain for these values. Okay, this is like a PID control. Okay, and these are the gains. Anyway, this is for the Y, but we just use one axis. We just use one. Well, this work is, I've done it in several months, doing you know, just a little bit in the afternoons, in the evenings, and most of them is copy and paste from the internet. Is, as you can see, I've done, you know, a lot of mistakes. Finally I came out with something useful anyways. This is to adapt the angle to scale the scale, you know, to put in the correct scale. Okay. And this is an offset value to adjust everything. And you have in here the EMA filter is a low pass, as you can see. This is for the LED. Okay, it turns on or off an LED in order it turns just there are two outputs, just the vibrator motor and the LED, and they work, they activate at the same time. Okay, just it was just to have a visual in order to testing. So this is the PWM value I put for the output to the vibrator through the BJT transistor. This is the value I used. This came after a lot of adjustment, you know. So its consumption is around 70 milliamperes at 3.3. Oh, I guess it's okay, the consumption. It works anyway. So it's the same as the LED. You turn on the output if this is the sensor value is less than the setup, the set point, sorry. So it compares with a set point and activates the value, the output. This just for adjusting the PWM. Anyways, this one is the final code, despite all of the draft I wrote. So I apologize for everything. That's pretty much it. I'm just gonna show you what I mentioned, that LED. I put it in a box, you know, in order to test it, and I tap off a cable in order to drive an LED, and I can have it in my hand, because there is one issue. You got to put the vibrator motor very closely to your back, you know, in order to feel it. It happens with any mobile phone, you know. You got to touch, if it's in here, and it vibrates, but you got to do it more compact, the package, in order to a better vibration transmission. Okay. Anyways, I'm just going to show you how it works. Vibrates. So you got in here. Here is working, okay, and then once we get to a set point, it turns off. You can adjust when it's going to turn on and turn off. And the low pass filter is in order not to activate the output if you are walking, for example, okay, it doesn't activate. Without low pass filter, it would activate at this time, okay. So it's pretty much it. I mentioned the Bluetooth. I can show you right now how it behaves. Sorry about that, because I'm using my mobile phone to film this. So I use the BLE terminal. I guess you can use any terminal for Bluetooth available. And you can reduce the power, I guess, by taking off all the LEDs from the gyro and the Arduino. I guess you can reduce the consumption on low power mode, as well reducing changing the crystal from the Arduino. Instead of using 8 megahertz, perhaps using 4 megahertz, less consumption. Perhaps you can get a transistor, no, a BJT transistor, perhaps some sort of MOSFET, and you reduce as well the consumption. But I think it's good enough. In between, you know, it draws 100 milliamps when in total with the vibrator activated, and when it's not, is around 24-25 milliamps. Okay, so in a 250 milliamps hour battery, in between 2.5 and 10 hours of life. Alright, so I think that's all. I see you next time. Perhaps I upgrade this prototype. Okay, bye bye.